Okay, so this video is going to be on how to do unit conversion on the SAT. I just feel like I need to make this video because even though this is something that doesn't appear too often on the SAT, nobody is really teaching it in the right way, at least from the videos that I've been seeing. So here's how to actually do unit conversion. When I say unit conversion, I mean SAT problems in the math section where you get some kind of unit, like it could be, I don't know, meters, it could be, I guess it could be feet, potentially, it could be, I don't know, degrees even, radians, and you're trying to convert it to some other unit, like maybe go from feet to miles, kilometers to miles, meters to feet, that kind of stuff. So how do you do problems like this? Oh, also, if you want to know why you should trust me, I've personally scored a 1550 on the SAT. I've helped hundreds of students improve their SAT scores already, and my goal is to make the channel you're watching right now the best SAT YouTube channel on the internet. Okay. So unit conversion, the way to think about this is it literally does not matter at all what unit you're dealing with. It doesn't matter if you're dealing with feet. It doesn't matter if you're dealing with meters. It doesn't matter if you're dealing with degrees. You solve the problem the same way. Even if like I did something where like, I don't know, maybe I take pieces of paper and I give my autograph on it and I start selling them. Nobody cares about me. So those would probably be selling for like maybe, I don't know, $5. I can make a unit conversion of how many autographs it takes to get $5. Or I could say something like, how many autographs could you buy if you have $100? That'd be 20. How many autographs could you buy if you have only $2? I guess you could buy, I don't know, maybe like 40% of an autograph. I don't know how that really works. But yeah, so that is how unit conversion makes sense. Now here's how you actually do it on the SAT. What you should do is start by writing a box chart that looks like this. It doesn't matter how many of these lines you do. It doesn't matter anything like that. All that matters is that there's one line going lengthwise and a bunch of lines going top to bottom. Okay, so that's the first step. Then what you do is you take the thing that you have and that you're starting with. So for example, the next problem I'm about to say with hours. So I would take hours and put it up here, 3 hours. Then what I do is I go diagonal to that on the next thing down, or it could be up if I started here. And I then in that place do that same exact unit and just whatever number I want next to it. So I could say 1 here. So literally does not matter at all which number I choose. It just has to be the same exact unit. And then I put in how many of the next unit is in that unit above or below that new thing. So in 1 hour, there are 60 minutes. So I could put in here 60 minutes. Keep in mind, you have to adjust it based off of whatever number you put down here. So if I chose something like, I don't know, 5 hours, I can't just put 60 minutes. I now have to put 300 minutes because there are 300 minutes within 5 hours. I do that for as many units as I want to, and then finally I just put this all into Desmos, I multiply together the stuff at top and divide it by the stuff at the bottom. So literally this could look like 3 times 300 divided by 5. So therefore 180 would be the answer to this problem, 180 minutes. And so I guess I kind of already spoiled it, but yes, that would be the answer to this problem. If I'm trying to do it again just to show you a bit of a simpler way, so I could say here 3 hours, and then go here 1 hour is equal to 60 minutes. That's the final unit because hour is 2 minutes. And then I equal that together. I do 3 times 60 divided by 1, and that gives me 180. One thing you should know is that there also is a way to check this to see if you've made a mistake. So like you could see here, if you just cross out everything that's both at the top and the bottom, it should leave you just the unit you're trying to solve for. So for this here, there's 1 hour at the top, 1 hour at the bottom. So therefore all that's left is minutes. And that makes sense because what we're trying to solve for is minutes. So that works. That would check out. That makes sense. It's the right answer. Let's just do another example like this. So 200 centimeters to meters. So I put here 200 centimeters. And then how many meters are in a centimeter? If you do not know, it will probably say in the problem. So you literally do not need to memorize any of this stuff. It will just say in the problem for any common stuff like this that you may not know. But I do know, so meters to centimeters, I've put centimeters at the bottom here. If I do 100 centimeters, that's equivalent to 1 meter. Okay, so that is pretty good. So I could just do here 200 times 1 divided by 100, that gives me 2 meters. If I'm unsure how this works, I could just cross out this. Yes, all we have left is meters. So this is literally it. There are a few more advanced things you should know, but besides it, this is literally all you need to do to solve a problem like this. So if you're out here complicating this and making this feel so much more confusing than it has to be, stop. This is how you do it. 2 square feet, 2 square inches. Okay, this is where most people kind of give up on these problems because this is where it actually gets slightly more confusing, but actually not really at all if you do what I'm about to do here. Okay, so 2 square feet. That would be 2 feet, and I would just put this 2 at the top here. Now what I do is the exact same thing, except now I have to do it double the amount of times because we have a 2 here, not just basically a 1 like it would be here. When I have this, it's basically saying 1 meter to the first power, 1 meter to the first power. Now it's saying 2 feet to the second power. So I put here feet, And let me just put their feet, and let's do 1, and there are 12 inches in a foot. So keep in mind, if we're trying to cross out stuff here, all I'd really be crossing out is that 2. So we get rid of that, but we still have the feet here. There's still the regular feet hanging around. So I have to put here another 1 foot is equal to 12 inches to get rid of that one now. So I do that, and then finally we can eliminate that feet, and now we have 2 times 12 times 12, and yes, inches times inches, inches squared, that makes sense. It would be inches to the second power for the answer. So therefore, this would just be all we have to do. So 2 times 12 times 12, and then divide it all by 1 times 1. So 288 inches squared would be the answer to this. So all you have to do to get rid of this square thing is just do the exact same thing twice. Literally nothing else. If you're confusing it more than that, stop. What if you have something like this though? 60 miles per hour to meters per second. All you do is just the exact same thing, except now you have something at the top and at the bottom. So I'd say miles per hour, so basically 60 miles per 1 hour. And then I do the rest of it for each unit. So miles to meters, I would put 1 mile down here. And then in case you did not know, there are 1609 meters in a mile. But again, this would be shown in a question if it asks you something like this. So you do not need to memorize that. And then we can see here, that would be the meters. And we're done with the meters because if we do this, we can cross out that and cross out that. We just have meters. But what about the hours here? Because hours is not what we're trying to solve for. We're trying to solve for a second. So then I would go over here and do 1 hour. And then I would put here 60 minutes are in 1 hour. But that's still not the answer. We're trying to find per second. So then I could go ahead and do 1 minute is equal to 60 seconds. Are we good now? We can see, get rid of that, get rid of that, get rid of that, get rid of that. Yes, we just have meters at the top, seconds at the bottom. So I can just go ahead and do now 60 times 1609 divided by 3600. That would be 26.8 meters per second. Like, honestly, you may be watching this video and you may be thinking that I'm like missing some important detail here because it may seem way too easy based off what you're expecting. But no, literally not at all. Like, this is literally all there is. And that's why I'm so frustrated by people who don't explain it in this way, because it's literally this simple. One more example here before we do some practice problems. You can have this radians to degrees. This may seem like it's some weird thing, but it's actually just exactly what we've been doing already. Radians is just one way to write an angle. Degrees is another way to write it. So I could just say here 56 radians. And then in case you don't know, if you have radians here, 2 pi radians would be equivalent to 360 degrees. So that's literally it. Then I can go ahead and cross top and the bottom radians. And that's literally it. So I just multiply this out again. Okay, so 3,208 would be the answer here. Okay, let's just do one quick practice problem. So we have a rectangular park with a perimeter of 2 kilometers. The length of the park is in the same ratio to its width as 5:3. What is the area of the park to the nearest square foot? We do have to do some non-unit conversion stuff just to start this problem off, but that was discussed a little bit more in my area and volume video if you want to see an overview of that. Perimeter of 2 kilometers, that means if we add together all of these sides, we get 2. And this is the length is in the ratio of 5:3. So we can basically say here 5x for the length and then 3x for the width. We have to put the x here because this is just the ratio. It's not the exact measurements of the stuff. What we could just do is say 5x1 plus 5x1, because we know we have to have 1 at the bottom here as well, plus 3x1 plus 3x1 must altogether be 2. So we know there x must be 0.125. So then the area of the park would literally just be 5x1 multiplied by 3x1. That'd be 0.234. Okay, so 0.234 kilometers. The important thing we have to keep note of here is that this is kilometers squared. Whenever there is area involved, it just automatically becomes squared. So keep that in mind. That's just kind of an area volume thing you should know. For volume, if there's ever volume, it's automatically cubed. So yeah. We would start this problem off by saying 0.234 kilometers squared. And then we have to go through this process again. So this is going to be kind of tedious. First, let's get rid of the kilometers. So we do 1 kilometer is equal to 1,000 meters. And then again, 1 kilometer is equal to 1,000 meters. And then now that we've gotten rid of the kilometers, we have to do the same thing with the feet. So we would say here 1 meter is equal to 3.281 feet. And again, 1 meter is equal to 3.281 feet. Okay, just to check to see if everything is right, we can just cancel everything out to make sure it works. So cancel 2 kms, 2 kms, 2 meters, 2 meters. And yep, we have feet, 2 of them, because that would make sense to be feet squared, square feet. 0.234 times 1,000. I'll just put in these extra decimal places real quick just to make it. Okay, yeah. So we can see here definitely would be D for the answer of this like 2,523,000 number. So yeah, that's it. Okay, that's it. That's all I want to say in unit conversion. Pretty simple. Just understand this basic thing. Shout out to my chemistry teacher back in like 10th grade for teaching me this because it's goated. Also, if your SAT score is currently below 1400 and you really want to get it above 1400 for your next test, check the link in the description below for Mission 1400 Plus. What happens in here is every single student gets this full roadmap of a plan that I've developed to basically get anybody from any starting score to 1400 plus within at least 60 days. The median score increase in here is 120 points, which is a lot higher than most programs you'll see. So if you actually do the work, there's a very high chance of you seeing success. Plus, I'm doing a thing for the next month where anybody who joins in the free trial, I'll review their practice tests if they submit it to me. Speaking of which, there is a free trial. You can join for 7 days, no risk, no problem at all. We literally just had somebody in who joined this morning. They didn't want to stay in. They probably didn't want to pay. So they just left immediately and there won't have any risk, no charge, nothing. Good luck in the next SAT, guys. Make sure to always stay Gucci.